Alright, so we're doing a load word. So let's write down the load word instruction first. Like load word S3 to from S2. Right? Okay. So, and what's the format for this? The format for this is going to be opcode, and then RS, RT, and then offset, right? Our offset is 2. What is our RT? Our RT is S3, and RS is S2. The opcode for a load word is, I don't know. It's probably going to give it to us, and we're going to represent that in 6 bits, 5 bits, 5 bits, 16 bits, right? All right, cool. So for a load word, your opcode goes here. That's 31 to 26. Your RS goes here. Your RT goes here. And do we have an immediate? Yeah, we do. It's the offset, right? So we do have an immediate. So opcode goes to the control. We're going to worry about that later. For RS, you're going to read it. You're going to read the data in it. It's going to come to the ALU. That's a given. You don't have to do anything for that. For RT, for load word, we're taking whatever is in this address and you're putting it into this register, right? What is this register? This register is your target register, right? So we're technically writing in your target register. So if we're writing in our target register, we want to make the right register be that, right? Not some junk value. So you're going to choose 0 for this mux. You're going to come to this right register and you're going to stop, right? So you come down. You have an immediate. The immediate is going to get sign extended. It's going to come out with 32 bits. You're going to let that one through. You're not reading the data in RT, right? So you're going to choose mux value 1. The instruction immediate is going to go. It's going to come to the ALU. The address is going to be added to the immediate. So basically S2 will be added to the 2. After S2 will be added to the 2, the ALU result is going to come here. Now here, this gives you an address, right? We have to read the data from this address, and whatever data we get from this address, we want to put it in here. So here, we're not going to bypass it. We're going to go to the address. We're going to read the data in the address. We want that data to flow through, right? So we're going to choose 0 for this mux. Now, this wire will travel all the way back up to here, come to this write data, and then it's going to write the data in where? In this write register. And that's load word. All right, cool. So now you're at the control, right? So let's follow this line, which is a mux value, which gives you 0. It's going to be 0. Are we branching? No, we're not. Are we reading from memory? Let's see what this line goes. Okay, this line goes here. Are we reading from memory? Yeah, we are. We're reading the data. Memory to register. Where does this line go? Mux value. Okay, so we chose 1 here. ALU operation. We're adding the offset to the address, right? So the ALU operation is an add. Memwrite. Where does memwrite go? Are we writing to memory? No, we're not. We're writing to a register. So that's going to be 0. ALU source. That's a mux value, so that's 1. Register write. Are we writing in a register? Yeah, we are. That's a 1. So that's your load word done. So next up, BEQ, right? So let's do BEQ, S4, and then S5, and you're jumping to a label. So for the format for this is going to be, again, opcode, RS, RT with an offset. Opcode, probably going to give it to us. The RS is going to be S4. RT will be S5. Offset will be your label. You're going to represent the opcode in 6 bits, the RS in 5, RT in 5, and then label in 16. Cool? Cool. So your opcode is going to go here. Your RS is going to go here. Your RT will go here. And your label, which is your immediate, is going to go here because you have an immediate. Cool. We're gonna worry about the opcode later, as per usual. RS, you're gonna read register, read the data, it's gonna come to the ALU. For RT, we wanna compare if those two things are equal, right? So we have to first make sure we read it. So we're gonna read it, it's gonna read the data in it. We're gonna let that go through, it's gonna come to the ALU, right? In this ALU, what we're gonna do is subtract. Because if you have two of the same things, like if you have 2 and you're comparing if 2 is equal to 2, if you subtract both of them and you get 0, that means it's equal. So the ALU is going to subtract them. And if it gets a 0, then we're going to come here and we're going to give it a 1. Now this is where the control units come in. For the control, we're branching, right? So branch will be a 1. So we're going to supply a 1. This is an AND gate. For AND, if you get a 1 and a 1, you're going to output a 1. And this controls this mux. So you're going to choose a 1 here, right? But what are we choosing a 1 for? Let's follow the line and backtrack. So it goes all the way here, here, here. Oh, okay, cool. That's your immediate. So your immediate is going to get sign extended to 32. It's going to come all the way up. It's going to get shift left 2. And then you're going to add it. So it's here, right? But like you said, we need another place to add it. We need another input. So what is this line? This line, okay, you're adding 4, but what are you adding 4 to? Okay, this is the current instruction. The current instruction, it automatically gets the next instruction because PC always holds the address of the next instruction. It comes here, and then here, you're going to add that address to the immediate because you're jumping. You're going to add that result. The mux value you chose is 1. It's going to go through. It's going to come all the way back down to the PC, which will give you the address of the next instruction that you're jumping to because you met the condition. Both of the registers are equal, right? All right. Now let's do the control values. So destination register. What did we choose here? This is a don't care value because like we don't have a destination for the register. So I think you can put a 1 or 0 here. Mem read. Are we doing anything memory related? No, we're not. So mem read will be a 0. Mem to register. We don't even make it to this mux. So I think this is also another 0 or 1 value. For ALU operation, remember I said we're subtracting them? So we are subtracting them. If it's a 0, we're branching. For memory, are we writing to memory? No, we're not. ALU source, that's a mux value. That's going to be a 0. Register write, are we writing to register? No, we're not. We didn't even choose a value for that mux. It's a don't care value. So that's going to be a 0. And then that's basically a branch on equal instruction.